Hello my dear students, today I am here to understand the concept of classification of haloalkanes. Okay, so we know that there are three kinds of haloalkanes, that is 1 degree, 2 degree and 3 degree. So how you identify these three kinds of haloalkanes? But I have the tricks to find out the three kinds of haloalkanes. So first of all we take the examples of this, that is carbon. There are 3 hydrogen and 1 Cl. So this is the halo groups, and halo group is attached with the carbon atom which contains 3 hydrogen. So you must have to remember the halo groups which is directly attached to a carbon atom, and that carbon atom which contain at least 2 hydrogen atom is known as 1 degree. So this is an example of 1 degree haloalkanes. If we take this example CH3CH2Cl, so here the halo group Cl is attached with this carbon atom directly and it contains minimum of 2 hydrogen atoms, so it is 1 degree also. If we take the example of 2 degree, then we see the chloro group, that means the halo groups. Halo group is directly attached to this carbon atom and it contain only 1 hydrogen atoms, so it is known as the 2 degree haloalkanes. And if we take the example of 3 degree, then we see the example is something like this. The chloro groups which directly attach to this carbon atom and it contain no any hydrogen atom. It is directly attached with the 3 alkyl groups CH3 CH3 CH3. If we place the C2H5 here, then that is also known as the 3 degree haloalkanes. So 3 degree haloalkanes is that which contains one chloro group that is directly connected with a carbon atom, and that carbon atom is directed with 3 alkyl groups. There will be the absence of hydrogen atoms, so there will be no any hydrogen atoms. Okay, so this is the basic concept of the 1 degree, 2 degree, 3 degree haloalkanes. Okay, but the another problem rises when we see the another kind of classification of haloalkanes, that is vinylic, allylic, benzylic and aryl halides. Okay, so how we remember these 4 kinds of halides? So I have a tricks for you, and that is the RV and benol. RV ka AR means aryl, VI means vinyl. So in that halides, the chloro groups, that is halo groups, will directly attach with the sp2 carbon atoms, and in the case of benol sp3, you have to remind these two things. Okay, you have to remind these two things, RV and benol. In the case of benol, ben means benzylic and all means allylic, and in that compound the chloro groups, that is halo groups, is directly attached with the sp3 carbon atoms. Okay, so let us take the example. First of all, RV. So RV ka AR means aryl, so there must be a benzene ring because it is aromatic. It is its origin is from the aromatic. So the benzene group is something like that, and these all carbon atoms are sp2 hybridized, and it is in chloro groups, that means halo groups. So it is the halo group Cl. Cl is directly attached with this carbon atom. Okay, so it is the example of aryl halides. And if we take the another example, that is vinylic halides, we see that CH2 double bond CH singly Cl. So chlorine is attached with the carbon atom which is sp2 hybridized, but there is no aromatization, there is no benzene ring. Okay, so it will be the phenylic, but the carbon atom by which the chloro group, that means halo groups, is attached is sp2. So both the carbon atom is sp2 because this bond is double bond. And if we take the another example of this group, that will be something like that. There will be cyclohexene, and these two carbon are sp2 hybridized. And if we bonded halo groups from this carbon, then it will also call the vinylic halides. If we draw it again, it will be something like that. So it is the example of vinylic halides. Now we take the benzylic and allylic. So how will you draw the structure of benzylic and allylic halides? Let's see. First of all, benzylic means there must be a benzene group, there must be a benzene ring. Okay, so here all carbon atoms are sp2, that are sp2, this is also sp2, this is also sp2, 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 sp2. But we know that in the case of benzylic halides, the chloro groups, that is halo groups, is directly attached with the sp3 carbon atom. So the structure will be something like that: CH2Cl. This carbon is sp3 because this is not this is singly bonded with the sp2 carbon atoms. So it is, this carbon atom is sp3 hybridized, and the benzene ring, the carbon atoms of benzene rings are all sp2 hybridized, but this carbon is sp3 hybridized. So the halo group is attached with this carbon and it is sp3, so it is known as the benzylic halides, known as the benzylic halides. If we take the example of allylic groups, then what will be the product? Then what will be the example? The example will be something like this: CH2 double bond CH bond CH2Cl. Now we see this is sp2, this is also sp2, but this carbon atom is sp3, and here the chloro groups, that means the halo groups, it directly attached to this carbon atom, that is completely sp3 hybridized. So the example of allylic is it. And if we take the another example of allylic is something like this, that is benzene ring, sorry, this is not benzene ring, this is cyclohexene, that will be cyclohexene, there will be only one bond, so it is cyclohexene, and this is sp2, this is sp2, this two carbon is sp2, but this carbon is sp3, this carbon is sp3, this is also sp3, this is also sp3, this carbon is also sp3, this carbon is also sp3. So if we attached halo groups with this carbon atom, then it will be the example of allylic halides. Okay, I hope you understand it properly. Thank you, have a nice day.